is connected to a string. So the ball is going to move in a circular arc and it goes up a height of h and finally reaches a maximum height. And now we are supposed to draw and label the free body diagram for the ball at height h. Now, drawing the forces would be simple, but since it's a two marker, we need to be careful regarding the direction and the size of the arrows with which we are representing the different forces. For example, what do you think? What are the different forces acting on the ball? First force will, of course, is the mg weight acting downwards. And since the ball is connected with a string, there will be a force which is called tension force inside the string. This will give us 1 mark, but we need to be very careful regarding the length of these arrows. So how do we make sure that we have the correct size and the length of these arrows? That is where net force will help. Let me explain with a quick example. So imagine even in this situation, let me draw mg with some random length arrow. This is your mg, and the direction of tension, for example, is this. So here I have hypothetically made the lengths of the arrows of tension and mg. All we need to do is figure out the direction of the net force. And how do we do that? Using the parallelogram law. So all we need to do is first complete a parallelogram using the two arrows. So let's say it goes like this. I have drawn an approximate figure. In the exam, of course, you can use the scale. After drawing the parallelogram, now all we need to do is draw the diagonal of this parallelogram, and that will give us the direction of the net force. So in case the lengths of the arrows which we have drawn are correct, this should be the direction of the net force. So how do we cross check the direction of the net force? For that, we go back to the diagram. We already know the different forces mg and t, but what is the direction of the net force? So let us draw this diagram again just for more clarity. So we have mg acting downwards. Then we have T tension acting along the string. We have to figure out the net force. We already know that the ball is actually moving in a circular fashion. So remember, circular motion deals with centripetal force. So centripetal force is the net force which is acting towards the center of the circle. In this case, this is the center. So how do we figure out the FC, centripetal force? So imagine this particular angle is theta. So let's say this angle is theta. Now what we need to do, we will break the mg into two components. One component will go this way, another component will go this way. This component is basically tangential to that circular arc. Now, if this angle is theta, so this particular small angle, let me label, this will also be theta. So now we can clearly state that if I draw an arrow in this direction, so the component of mg in this direction will be mg cos theta, and the other component which is tangential to the circular arc will be mg sine theta. Now, if we recall, centripetal force is the net force acting towards the center. So in this case, T tension is acting towards the center, mg cos theta is going away from the center. So we can write Fc is equal to T minus mg cos theta, which will be equal to mv square by r, where v is the speed. mv square by r is the formula for centripetal force. Now, do we have the value of v of the ball, the speed of the ball at the highest point? We can deduce that. Since the ball is already at the maximum height, that means the ball will be instantaneously at rest. So at that moment, we can say that the ball is stationary, hence the velocity is zero. So the value of speed v will be equal to zero. So if we put right hand side of this expression to be zero, we can write T is equal to mg cos theta. Hence, now you can say that T and mg cos theta cancel each other out. So the only remaining force is mg sine theta. Hence, in this case, we can write the net force acting on this ball pellet system is mg sine theta. Now, for this question, we are not really interested to know the magnitude. We are supposed to know the direction. So, since the net force is mg sine theta, and what is this direction? This direction is tangential to the circular arc which we have drawn. So, in the free body diagram which we had made, We just have to be a little careful that the net force which we have to show should be tangential to the circular arc. So even in this diagram, let's say if I draw a circular arc, just for clarity, let's create a separate diagram. So first of all, let us draw a circular arc with a dotted line. This is your circular arc. All we need to do is draw a tangent at this circular arc. This will be your direction of your net force. Now we have to draw tension and mg in such a way that the direction of net force should be in this direction. So how do we make sure that happens? All we need to do is, first let's draw dotted lines. So mg, the weight, will be along this dotted line, and tension is of course along the string. So let me draw a dotted line along the tension as well. Now let us try to create a parallelogram out of this. So if I draw another dotted line over here, and then another side of the parallelogram which is over here, and in this case, now let's connect the dots. If I draw this arrow, this is the mg, the weight having the right length. And similarly for the string, we can draw an arrow. Okay, this arrow will represent the tension T. So if you observe carefully, we have worked backwards. First, we have identified the direction of the net force, then created a parallelogram, and then we have drawn the two constituent forces, tension and mg, because only then we can draw the forces having the right length. T and mg are having the perfect lengths in this case. And that is why this question was not worth 1 mark. You will get 1 mark if you can show T and mg. The other 1 mark is to just check whether you as a student can draw the correct lengths. And in any case, let me show you the official IB solution for this question. They have mentioned this. We have to draw a arrow along the string, which is tension. We need to label it. And then we have arrow downwards of approximately correct length. So it is an approximately correct length, of course. So we need to make sure again, first step is to figure out the net force, which is, remember, tangent to the circular arc, which will be this red arrow. And then accordingly, we can draw the correct lengths of the tension arrow as well as the weight arrow. Indeed, a tricky question, but that is how we solve such a question. Coming to the part D of the question, we have to figure out the value of the height. So initially, we had deduced once the pellet had gone into the ball, once it got embedded, then the ball pellet system moved with a speed of v, and the value of that speed was 1.27 meters per second. And then the entire system moved in a circular arc until it reaches the maximum height. Now, at maximum height, we already know that the instantaneous speed of the system will be zero. So let us write final speed of the ball at the topmost point will be zero. So how do we figure out the value of height? We will use the law of energy conservation. So now let me label, let's say point A is the bottommost point and point B is the highest point. So according to the law of energy conservation, total energy at A needs to be equal to the total energy at B. Total energy we know is a combination of kinetic energy as well as potential energy. So we'll have to do for both A and B. So on the right hand side, kinetic energy at B plus potential energy at B. So initially, we are considering the point A. This is the point where the pellet and the ball are moving as one system. So the total mass will be 252 grams, like we had seen earlier. So kinetic energy will be half 252 grams. Let's convert that into kgs. And then the speed squared, half mv squared. So speed will be 1.27 squared plus potential energy we know is mgh. But for the point A, we can assume the height to be zero. So at the bottommost point, potential energy we will take as zero. At the highest point, when the entire system reaches the maximum height, we saw speed was zero, hence kinetic energy will be written as zero plus potential energy will be mgh. But be careful, m will be the total mass. So even in this case, we will write 252 grams. So let's convert that into kgs. M into g into h. So this is the entire equation. So all we need to do is simplify this expression. So, okay, I have made a small mistake here. This should be 10 to the power minus 3, not 10 to the power minus 2. So, 1 second, let us correct this. 252 grams, which after conversion will become 252 into 10 to the power minus 3. And now if we simplify this, 10 to the power minus 3 factor can get cancelled out from both sides. In fact, 252 will also get cancelled out. And now let us write down the expression half into 1.27 squared will be equal to 9.8 into h. And now if we try to make h as the subject and figure out the value of h, we will get h as 0.0822 meters. And let's say if we want to round this off to two significant figures, then the value of h can be written as 8.2 multiplied by 10 to the power minus 2 meters. And that's how we find the value of height using the law of energy conservation.